Unit 10, Recursion. Topic 10.1, Recursion. Back in Unit 4, we introduced loops as an iteration tool. As I am sure you have seen by now, they are very useful. Take a look at this scenario. You have a main box with multiple nested boxes inside of it. One of these boxes stores a key. You could approach the process of finding the key using a traditional iterative approach or by using recursion. The iterative approach could look something like this. The recursive approach could look something like this. Recursion is an iterative process where a method calls itself. A recursive method is a method that calls itself. Is this method considered recursive? There is no call to the method mystery inside the method mystery, so this is not a recursive method. Is this method considered recursive? Yes, any method that contains at least one call to itself is considered recursive. Which line in the method factorial contains the recursive call, or the call to the same method? Line 6 contains a call to the same method, which makes it a recursive method. We use recursion to break a complex problem down into a slightly simpler version. We continue to do this until we get to a problem that is so small it is easy to solve. A recursive method has two basic parts you should be able to identify: the base case and the recursive case. Recursive methods contain at least one base case, which halts the recursion, and at least one recursive call. The thing that stops a recursive method from calling itself is called the base case. A method can have more than one base case. In other words, more than one way to stop the recursion. We just said that every recursive method must have at least one base case which halts the recursion. This is usually an if statement that causes the recursion to stop by just giving an answer without needing a recursive method call. You could also think of it as a simplest case where you can give the answer right away. Which is the base case in this recursive code? You can see the answer regarding the value of n. This line clearly states n is equal to the value 0. Where is the recursive call in this code? When you see the name of the method inside the method itself, that is the recursive call. In this case, the method called factorial. We can say that the statement containing the recursive call is called the recursive case. What is the value of n when this method stops calling itself, when it reaches the base case? This method stops calling itself when n equals 1, found in line 3. Where is the recursive call in this code? Again, it's where you see the method being called within itself. In this case, the method product is being called. The recursive case is a statement that contains a recursive call. What is or are the values of the variable bunnies when this method stops calling itself, or, in other words, when it reaches the base case? This method stops calling itself when bunnies equal 0 or 1. Where's the recursive call in this code? On line 5, where the method bunny ears is being called. The recursive case contains the recursive call. In this scenario, what might you consider the base case? What about the recursive call? Here's your base case. Here's your recursive call. Given the defined method, what does factorial 6 return? Start by identifying the base case and the recursive call. One way you can set up tracing a recursive method is by setting up the recursive calls until you get to the base case. Once found, you can go back, substituting the values until you reach the first call. My AP class daily video shares how to set up a table to trace a void recursive method. The AP class daily video also shares how to set up a table to trace a non-void recursive method that uses the return statement. Each recursive call has its own set of local variables, including the formal parameters. Each factorial n call has its own local variables, including formal parameters. In this example, they are the values that replace n and n-1. Parameter values capture the progress of a recursive process, much like loop control variable values capture the progress of a loop. Notice how the parameters 5, 4, 3, 2, 1, and 0 capture the progress of this recursive process. Any recursive solution can be replicated through the use of an iterative approach. Writing recursive program code is outside the scope of the course and AP exam. You only need to know how to trace recursive methods, figure out what they return or print. You will not be asked to write a recursive method on the exam. Recursion can also be used to traverse string, array, and array list objects. The 10.1 daily videos 1 and 2 provide examples of tracing recursive methods in more detail.